The reason why we started having this parent academy, y'all are going to hear other grade levels start having them too. Fourth grade was actually the first one to start this because several years ago, when it was like the beginning of Common Core, in fourth grade, we noticed a big problem because we were teaching these kind of new strategies. Kids were going home, parents were like, we don't know how to teach this. And they were then teaching them the way that they learned. Okay. Nothing wrong with the traditional way, and I promise you guys we will teach them the traditional way. It is still part of the Common Core standards. It just comes a little bit later, okay? But what we were finding is that those kids that were struggling, a little bit with our way, they were also struggling with the standard way, and now they have all of that all in their head, and trying to separate that and getting them to master one way was extremely hard. So we decided to start having a parent academy so that we could teach you guys how to use the Common Core strategies. Also, we found that parents hate Common Core. It's like an American thing. Like all parents hate Common Core over here against the teachers, and it's this thing. So what we're trying to do is, I'm not going to expect you to love it by the end, but I hope that you understand it and you can kind of go, okay, it's all right. I understand how to do it. I understand why they're doing it. Maybe I don't love it, but I can deal with it. So that's our goal. So multiplication and division are the two kind of skills in fourth grade that is very different from how parents learned it growing up. All right, I don't know why that's there. Okay, so today I started teaching the area model. Before the area model, I taught the distributive property, and that goes in the kids' homework. That was when we stretched it out. I'm going to give y'all some more examples of that. We have area model first here just because that's the main way that we do it in fourth grade. We kind of show them all of the different strategies, and then we kind of stick with area model because it's typically the one that all the kids can do, because it's very organized and it's very obvious how to do it. Well, for the kids, probably not for y'all right now. All right. So what is the area model? What's wrong with the traditional way? There's nothing wrong with the traditional way. But this is why we teach them this first, okay? So in fourth grade, in elementary altogether, place value and understanding numbers is like our big emphasis. So it's no longer, here's this skill, you memorize the steps. Every time you see a problem that looks similar to this, these are the steps you do. Okay, we're trying to get away from that, the kids memorizing steps and really understanding why they do what they, why they are multiplying, why they are dividing, so that, awesome baby, so that whenever kids are presented these problems, word problems or real life problems, they know, oh, hey, I know what this is dividing because I'm going to be putting these in equal groups, and they really understand what they're doing when they're doing the dividing, so it just makes sense. All right, also, okay, here's the standard multiplication, all right? This 0 right here, okay, several years ago, we just call it the happy face or placeholder, or don't forget to put your 0 because it's got to be there, 0, right? Okay, that's probably how y'all learned, all right? There was probably no, well, I just do it because that's the step, right? That's why you do it. But our kids, after they go through area model and the distributive property and all those different things, they truly understand what multiplication is that the values of these numbers. And so when we get to this point, I don't teach them to put the 0 there. They figure it out themselves. They do, I promise, they do. Especially in this class, they do, okay? So they can tell you why this 0 goes here is because this right here, this is actually partial products too, okay? So because this problem is actually 345 times 5, and your product of that is here. And this problem is 345 times 20, and your product is here. So that 0 is there because you're not really multiplying by 2, even though we were taught we were multiplying by 2, right? You do 2 times 5, right? But really, they are multiplying by 20. Now, we teach them that once they put that 0 there, they can then pretend they're just multiplying by 2. And because that 0 is here, their place values will end up in the right place. And they compare this. We do like Venn diagrams whenever we teach the standard way. And the standard multiplication is in the Common Core standards for 5th grade. This class, so your kids, I will teach the standard way by the end of the year. So, and I will also teach them the standard way of dividing. That's a 6th grade standard. But we will either learn that at the end of this year, just kind of depends on how much time we have. We got Rock Eagle and all that at the end of the year, or the beginning of next year. I do teach 2 blocks of advanced math in 5th grade. One we just call advanced math, and that's like we go deep into the 5th grade standards. And in that one, I teach standard division at the end of the year. And then I have accelerated math, and we teach 5th and 6th grade standards in that class. And in that one, I teach standard division at the beginning of the year. All right, so let's go to the next slide. We got to get busy because I want to spend most of the time on division. All right, so what does your 4th grader come to us knowing? They know what an array is, okay? An array is any time that you arrange objects in nice, neat columns and rows so that, you know, you can go, I have 6 rows and I have 2 columns. 6 times 2 is 12. They know how to do that. I'm going to close this door. I have never taught, absolutely, I've never taught the door closed before, but up here I have to because of the bathrooms. That's the most obnoxious sound ever, is that hand dryer. Anyway, all right, they also come to us knowing expanded notation. They start breaking numbers down into their values when they are in kindergarten and 1st grade using base 10 blocks. These are base 10 blocks over here. I use them in every single grade level that I teach. So we have these represent units. Have y'all seen these? Did y'all use these when y'all were in school? Okay. No? Okay, so these represent units. So these represent your ones. Okay. These represent the tens place, the 10 rods. These represent the hundreds place. And then these represent the thousands place. Now, this is kind of off topic, but after Christmas, I do some magic. And I hold a unit in my hand, and I hold this in my hand, okay? And I turn that 1 into this, and this becomes 1. This becomes a 10th, and this becomes a, I'm sorry, yes, that becomes a, I messed up. This becomes a 1, okay? This becomes a 10th, this becomes a 100th, and this becomes a 1000th, so it kind of goes back. But using visual representations really helps kids understand what's going on. So anyway, so this is kind of like a step up from the visual anyway, what we're doing. All right, they also, before we start this, they know how to multiply multiples of 10. And so this is what we were kind of practicing last week. 20 times 4 is 80, 200 times 4 is 800. They know how to do those, and they know why it works. Because in the base 10 system, every place value, y'all know this, is worth how much? 10. Yes, good job. All right. Every place value is worth 10. So if this is 20, it's really 2 times 10. And every time you multiply by 10, every digit that you're multiplying moves up 1 place value. So that's why they understand that this is really 2 times 10 times 10. So therefore, you would move up in the on place value 2 times, and 2 times 4 is 8. So therefore, the answer is 800. And that 8 got moved up 2 place values, 1, 2. And so your zeros, okay, they help push your numbers up on the place value chart. okay? It's all confusing, I know, I'm sorry. I promise your kids have had like 3 or 4 weeks of this and not 10 minutes. So it makes more sense to them, I promise.
More sense now. When she brought it home, I was like, so multiple times. I don't know which, okay, lost me. But
Absolutely. And also teach them, because one of the things that we say all the time, we have 2 sayings that we say all the time, okay? We say mathematicians are efficient, okay? But also mathematicians understand why they're doing what they're doing. But once you understand why you're doing it, if you found a pattern, we look for patterns all the time in math. Once you found a pattern, a strategy that works over and over consistently, well then use that. Use that strategy, use that trick, okay? And that's what the standard algorithms are. They're a strategy that someone has used that they found was very efficient. They used it over and over and over again, they found that it worked. So we are building them towards those standard algorithms so that they understand why those standard algorithms work. All right, so that's an array, three rows, 13 columns, and they know how to do that. But do you know your 13 facts? No, probably not. But what we teach them, and this is the leads to the area model, is that if you have 3, we're going to keep 3 here, but 13, I can break into 10 and 3, 10 plus 3, okay? So if I do that on this array, it looks like this. Well, kind of like that if I could draw straight. Sorry, I had a monster drink, I'm a little shaky. All right, so then you would have 10 columns here, right? And 3 columns here, right? So instead of having to multiply by 13 now, I can do 3 times 10 is 30, right? So this is 30. And 3 times 3 is 9. So therefore, you would know that 3 times 13 is 39. Make sense? Yes. Okay. All right. By the way, this video, I will never watch it. Never. It would be in my nightmares to have to watch this video of me talking. All right. All right. So, that is basically the area model. Okay? So we have 3. We broke apart, we broke the 13 into 10 and 3. All right, so now we have 10 times 3 is 30. 3 times 3 is 9. Okay? So the area model is just, we're not going to draw the actual boxes. We're not going to draw the X's because that takes forever. All right. It's called area model because it's literally based on the fact of how area works. Area, do y'all remember the formula for area? Length times width, right? Length or length times height. It's 2 dimensions. It doesn't matter which 2 dimensions, but you're multiplying one dimension by the other. That's the basis for area model. Okay. However, if you were to do it to scale, you're going to end up with boxes that look super tiny like this. Okay. So also, when we're talking about mathematicians being efficient, one way that mathematicians are efficient, that they're able to be, we define efficient as quick and accurate. So one way that they're able to do that is to stay organized. And one of the best ways to stay organized, and we've used it for word problems, and now just multiplication problem, is to create a chart. So the way that we do area model is to create a chart. Okay? So here's your chart right here. I don't know exactly what page this is. Did somebody just come in? Let me give you this stuff. You got a packet here and a pencil. And at the end, if I forget to tell you, we'll do that survey and put it back on the table. Absolutely. Yeah, those are yours. I would like for you to keep this and read it tonight before you go to bed.
Every night. Help me go to bed.
Hey now.
Sorry.
I'm taking offense to that.
Come to my French class and then you can boo it all you want.
All right. So we have right here 25 times 6, so it's there. All right. What I teach the children, and this is what we did today. So we're at the very beginning of using this strategy. I don't give them the box already. I was nice to y'all, gave y'all the box, but this is how I teach it to the kids. All right, since we're going to do area model, we're going to draw a box. Okay, and I'm I'm gonna think about my numbers. I had 25 and I have 6. Hopefully I know my 6 times tables, and if not, at this point, we allow them to use their, what we call a start chart. That's those multiplication charts that they were supposed to be doing for homework, like, can I make it within 5 minutes? By the way, the purpose of that is, on tests, we're not allowed to give them any kind of tools like that. But if they need it, if they want it, they can make it themselves, and we can't stop them, okay? So on their scratch paper, for the milestones, or for the SAT if they want it, they can make that start chart on their scratch paper, and they can use that tool for the rest of their lives. Learning and knowing their multiplication facts is very important in my opinion. It just makes math easier. But whenever we're doing this, I want them to be able to focus on this. So I allow them to use their multiplication charts, their star charts, to be able to figure out the basic multiplication. All right, so anyway, hopefully we know our 6s. So we don't need to break that number apart. So I'm just going to write that here. Normally I write the one on the right on the top, just because it's closer to that side, and the one on the left because it's on the left. Yeah. All right, so I don't know my 25 times tables, but you remember that background knowledge? I do know how to multiply 20 and 5. So if I break 25 into 20 plus 5, then I can do that, and I know those multiplication facts. All right, so I'm just going to run to the left, write 20 here, and 5 here, and you read it just like you would read any other chart, okay? And this is exactly how you read a multiplication chart. So they are skilled in knowing how to do this. What you write right here is the product of the two numbers that go together for it, 20 times 6. When they are writing these numbers, remember we had gone over this is really 2 times 10, it moves it over once. I don't say that every time now. I say, we found a pattern. Every time that I have a 0 here, I know there's going to be how many zeros in my product? 1, okay? So we do that now. And sometimes I underline that to make it obvious. All right, then I do 6 times 2 is 12, so that goes there. And then I do 6 times 5 is 30. Now, at this point, if they did not line these numbers up, they would take them over to the side, 120 and 30. They would add those up for 150. Now, hopefully, they are being very organized, and it's easier if they write their zeros first to do this. But if they are writing these in the correct place values, I tell them they don't have to rewrite it. I would not tell any other class that, but I tell this class that because they are hopefully able to understand the importance of writing those in the correct place value. Okay, does that make sense? Yeah, good? All right, so you guys go ahead and try 42 times 3. We'll do that. Yeah, we're good. Although I might need some more packets because I'm down to 1, so if I have any other parents come in. So remember, the first step is to make your box, because we're doing the area model, and we know area is length times width, one dimension times another dimension. And I emphasize that because this and this are the same dimension. So they can't put a number here and here. That's not area model. It has to be one dimension times another dimension. And that helps them later on when we're doing area too. All right, so 42, what'd y'all break 42 into? 40 plus 2, right? So have 40 here and 2. And then since you have 2 numbers here, I'm going to break those apart. When I encourage the kids to do the line after they do the numbers, so that for any number of digits here and any number of digits here, it will automatically create their box for them and the correct number of columns and rows. So we have 3 here. All right, 3 times 40, that's 1, 0. 3 times 4 is 12. 3 times 6, my answer is 126. Know what y'all got? Woohoo, I didn't mess up. And y'all, I mess up all the time, okay? And I'm not ashamed of it. And I tell them that on the very first day. It's like, y'all, I've got so much stuff happening in my brain, I make mistakes all the time. When I'm writing problems up there, I'm probably thinking of 3 other things while I'm doing that. I'm going to make mistakes. And so one of my things, and there's a poster of it up there, that we say on top of mathematicians are efficient, is that it's okay to make a mistake. That's the part I say. And they say, as long as you fix it and learn from it. So their job in the classroom is to be watching me and catch my mistakes. Because I'm not going to yell at them for a mistake, as long as it's a mistake, and I have to tell them this or they will like get me on every little bitty thing. As long as it's a mistake that's going to mess somebody's learning up. If I forget a comma, you're going to leave it alone, okay? But if I write the wrong number, you're going to tell me, because that's going to confuse somebody else. So they are responsible for doing that. All right, so now this is what I would tell the kids. I'm not going to do this to you, don't worry. But I would say to the kids, and this is what I did today. All right, we just did that one problem, and it just had 2 digits times 1 digit. How would you make that same box? How would you do area model for this one? Okay? And they figured it out, y'all. Y'all got some smart kids, I'm telling you, okay? So, you would make the box, okay? And I'm thinking, well, I still know my 6's, so that one's good, but I don't know this. I don't know my 2,532 times tables. Don't know those. So, I'm going to break this one apart. So, you would break it apart into 5,000, 500, 30, and 2. So, this is where it really comes in that
2,000, not 5,000.
Thank you. See what I tell you? What I tell you? Thank you. Good job. All right. High five in the air. Awesome. Yeah, I did. Okay. You guys are so. Y'all know how I teach now. All right. So I'm going to now break this apart into these sections. So I draw a line in between 2,000 and 500. Draw a line in between 500 and 30. Draw a line between 30 and 2. Okay. And I put my 6 here. Do I need to draw any columns? No, because I'm not splitting 6 apart. And by the way, we did, when we were doing distributive property, we did do things like, well, will 3 plus 3 work? Could I do that? And it does work. And we tried it out. But is it very efficient to break apart 6? No. So we're not going to. Okay? All right, so 2,000 times 6, I have 3 zeros. 1, 2, 3. 6 times 2 is 12. 6 times 500, 2 zeros. Now here's the thing where we say, you know, mathematicians are efficient, okay? And this is kind of the hard thing. And I don't make them do that, but I encourage them when they're writing the rest of these numbers to write them in the same place values as they wrote the ones before. Because if they do that, they don't have to rewrite it. If they don't do that, it's okay, not a big deal, but you're going to have to rewrite it in the right place values. All right, so 500 times 6, that's 2 zeros. And this is the one that kind of gets them, because this is 6 times 5 is 30. Now, this is where a lot of kids make a mistake. They're like, well, I already have a 0. But no, okay, that's one of these zeros. It doesn't count. Okay, so I'm 30 like that, so 3,000. All right, 6 times 30, 1 0. 6 times 3 is 18. 6 times 2 is 12. Okay? And then we can just add these up, because these are partial products here. So we add these up, 2, 9, 1, 5, 1. 15,192. Cool? All right. We are going to do 2 digits by 2-digit numbers, okay? We also do this today. And this is what I tell the kids. How would you do that? So you start thinking, now I'm not going to make you do it, all right? But you start thinking, well, how would you do that? Because that's what your kids are thinking, and guess what, y'all? They figured it out. I'm not saying, I'm not trying to make you feel bad or anything, but your kids figured it out. They are. I love them. All right, so we have 45 times 23. I don't know either of those facts. So guess what I'm going to have to do? Break both of these down. So I'm going to do an area model, draw a box. How would I break apart 45?
40
plus
plus
40 plus 5. And how would I break apart 23?
20 plus 3.
20 plus 3. Now, some kids, they start getting confused when we have these two numbers here and two numbers here, and they start like switching places, like they would put, I don't know why they would do this, but they would put the 3 down here and 5 up here and all kinds of, so I do make sure to tell them that it's kind of like a sport, okay? This is one team, and this is another team. This team will play every player on this team, but you wouldn't battle your own teammate, right? You wouldn't do that. So you have to be on the same side as your teammate because you don't want to battle them. So I tell them, go back, look, 45, 45, 23, 23. I'm good, okay? Now, I'm going to draw my lines in between here. I have 40 and 5, so I draw one line. 20 and 3, I separate that. Another one, just like that. Okay, so now I have, in my chart, I have 4 boxes. And again, you read this like any other chart. So area model also teaches them how to read, charts that you would see in a nonfiction text. So we have 20 times 40 in this box, 2 zeros. 2 times 4 is 8. We have 3 times 40, that's 1 0. 3 times 4 is 12. 20 times 5, that's 1 0. 2 times 5 is 10. 3 times 5 is 15. Now with these, since they're all like this, it kind of depends. Sometimes we might just, if we lined them up nicely, we might go, okay, well this is 900 here, and this is 135 here, and then I come over and do 935. Although a lot of times they start getting messy when it's like this and they're not lining them up as nice and neat. So therefore we would just go over to the side and write every single one of these out to the side and add those up. And that's how I taught them today. I haven't showed them that, hey, you could just do that. I didn't show them that today. All right, so anyway, the answer would be 930.
It's 135.
135.
Yeah.
How did I do that? Oh,
Because you
wait a
just
minute.
left off the 1.
I did, because there we go. I did do that. See, thank you for paying attention. Good job. All right. Y'all are getting good at this. 1,035. That makes more sense. All right.
So, quick question. So yesterday you just taught them to do this through kind of basically expanded notation,
Yeah,
right?
expanded notation and strictly the distributive property.
Yeah.
And that is in here.
Mhm.
But because this is the main way we do it, like this will be the strategy that you will see, or that the kids will see whenever we're solving any kind of problem throughout the year. The teachers resort to this strategy. So we wanted to make sure that y'all really understood this one, so that, because it's the one y'all will see from now on. But yes, I teach the distributive property first, because it just lends itself a little bit better to that basic understanding, and it scaffolds to this. Because today what we talked about was, what was a good way, when we were working those word problems out, how did we organize that information? Well, we used a chart. Guess what? Mathematicians can use a chart as well when organizing the multiplication problems. So that's how we kind of melded that together. Do y'all think you have it, or do you want to try it? Think you got it? Okay, cool. We'll move on. This is the distributive property, okay? So here's the area model, and I'm just going to do the distributive property beside it. So this is what I do. So we break apart 24, and we keep the 6. So we have 20 plus 4 times 6. Now this probably looks like something that maybe y'all saw in middle or high school, right?
Algebra.
Yeah, algebra. Yes, absolutely. So it's getting them ready for that. Okay? And so the distributive property, which they learned back in 3rd grade, says that you can multiply this number by both of these numbers. So by the sum of 24. Anyway, y'all know what I'm trying to say. It's not coming out right. Anyway, so we do 6 times 4. Okay, they wrote this different than I do. I always start with this number. I don't know why, but I do. Okay, I always start with that. So, I don't know. That's not making sense to me. All right, 6 times 4. I'm gonna write it here. 6 times 4, and I always draw my lines, because if I don't draw the lines, I forget a number. And then 6 times 20. 6 times 4. And this again, I teach them, if they line them up here properly, they don't have to rewrite them. But if they don't, that's okay. Just make sure that you do go and line them up. So 6 times 4 is 24, right? I hope so. Okay. 6 times 20, that's 1 0. So I write my 0, and when I write the 0, I make sure that it is in the ones place. Y'all should have some. I gave 7 bags
Siller
to.
said she needed another bag so that it could be even. They have 2, but they needed 1 more.
Okay, yeah, that's fine. I don't have
Okay,
I got
perfect.
plenty.
Thank you.
Okay.
Sorry.
I should only need 2 bags for these. But yeah. All right. So we have. Oh, I'm sorry, I didn't finish. Okay. So 1 0. 6 times 2 is 12. Okay. Then we add these up for 1. Okay. I'm not going to spend a whole lot of time on this because this was what was in their homework. So I think y'all seen the distributive property a lot, right?
I'll go over that maybe more work. Please.
This is like all kinds of. Okay, maybe we're just doing that one example of it. Okay, and then they give you an example here, and they do it a little bit backwards. Let me get to a. We're just gonna go to this one because I do want to show y'all what it looks like with the 2 digits, the distributive property. So 25 times 32. Okay. So I would break apart 25 into 20 plus 5. And we talk about when we put it in parentheses, that means we're talking about the sum of 20 plus 5, which is 25. Okay? Times the sum of 30 plus 2. And I do try to use this language a lot with them so that they really understand what's happening. And they also know that you would do what's in the parentheses first if you were just looking at an equation. But in this case, it means the sum of. All right? So distributive property means that, and remember we have these are teammates, these are teammates. Okay? Every teammate on one team has to play every teammate on the other team. Okay? So I start over here, 2 times 5. Okay? And then I do 2 times 20, and I tell them, write your equations out first before you solve them. Because what happens is they start solving them, and then they forget to go back and do more of those. Okay? So I've got 2 done. Check. Now I'm doing 30. 30 times 5. And 30 times 20. All right? So we have 2 times 5 is 10. 2 times 20 is 40. 30 times 5, 1 0. 3 times 5 is 15. 20 and 30, that's 2 zeros. 3 times 2 is 6. And then you add these up. 0, 10, 6, 7, 8. 800. Right? Right. Okay. So, and your kids, by the way, today, yesterday, sometime, I can't keep it straight now, but they did, I said, well, what would that look like if this was like 425 times 32? And they were able to do that, figure that out on their own. And same thing with the area model. We did that with the area model, and they were able to do that. 2 by 2 multiplication and 4 by 1 digit multiplication are the standards for 4th grade. So like tonight, their challenge problem was a 3 by 3. That's not 4th grade standard, that's above 4th grade standard. But because they know how to do these and they understand that process, and they can apply that to this. I tell them that I am never going to give them a problem and we're going to ask them to do something that I have not given them the background knowledge to be able to solve. That I might ask them to solve something that I haven't taught them how to solve it yet, but they have the background knowledge to know how to figure out how to solve it. And so that's what we harp on in this class, so that they are you know, when they're presented with those real life problems, they're like, okay, this seems really hard, what do I know about it? And also, I have a problem that is this big, what can I do? Well, I can solve this part of it, and after you get that done, then you can solve this part of it, and then it seems easier. All right, partial products is the next step that we take after area model, and this lends itself pretty well to the standard algorithm. You see it starts looking like a standard algorithm, okay? What you do here is you start in your ones place exactly like you do for standard, and you go 6 times 3 is 18, but instead of carrying, I write the entire 18 here, okay? Now, this is where we kind of, the old way and the new way clash, okay? We're not doing 6 times 2. What are we really doing? 6 times
23.
No, not 23. We already done 3. 6 times 20, right? So 6 times 20 is 120. Now see? Okay? Now, I am done with the 6, and when I teach standard, I tell them to do this too. Done with that 6, okay? Because, again, remember, area model, this one player has gone against both of these players, right? So I'm done with him. He can sit down, he can sit on the bench, that's what I said. All right? But now, with this 4, is that really a 4? 40. No, it's a 40. So now you see, since they are doing this over and over again, this is really a 40. In that standard algorithm, they automatically know, wait a minute, no, I'm multiplying by 40. I have to have a 0 there, right? So 40 times 3 is 120, okay? And then here, what would this fact be?
20 times 40.
Yeah, 40 times 20 is 800. So you are multiplying the values of each number by each number, and you're just writing them down here. And any carrying just happens in regular addition down here. Okay? So that's partial products, and that's where we get before we teach the standard way. All right. So is that making sense? Multiplication, not so scary anymore.
Do they even need the traditional way though if they have all this other stuff?
Mathematicians are efficient. The standard way is the most efficient way.
Okay.
So they don't need it. No, they don't need it. But the standard way is the most efficient way. It's the fastest way. So if it's the fastest way, we're going to eventually use it. Okay? All right. This is. Really wanted y'all here for, and I got to rush through this. I'm sorry. All right. So division. Okay? We start division by talking about sharing. And I will literally, y'all, I do this with my first graders. I do. It doesn't look exactly like this, but with my first graders, I say, hey guys, there's 15 of you. I need to put y'all in 3 groups today. How can I do that? And they start thinking about, okay, well, since there's 15 of us, then we can, if we put 1 in each group until we have 15 done, then we have our 3 equal groups. Okay, so that's kind of the thing here. These represent your base 10 blocks. And we will use some base 10 blocks. We won't do this for very long, but we will use some base 10 blocks. We probably won't be drawing them, but we might actually just use them. So in here, 136 divided by 4, you think, okay, well, I know that I can do it in 4 different groups. And what can I put in each group evenly? Can I put 10 in each group? Yes, 10, 20, 30, 40. Can I put another 10 in each group? Let's see. 50, 60, 70, 80. Okay, can I do it again? All right. What was that? 80, 90, 100, 110, 120. Am I going to be able to do that again? No, I'm not. I'm not going to be able to put another 10 in there. So what could I try? Units, right? So they might say, you could try putting 2 units in each. Okay, what did I land on? Do y'all remember? 190? Wait, what is it? 120, 120. Okay, so 122, 124, 126, 128. Right? Okay, so now I'm almost there, right? I'm trying to get to 136. Okay, so then you're getting pretty close. So then you might want to be just trying all ones, okay? 128, 129, 130, 131, 132. 133, 134, 135, 136. You see what you drew, okay? One of these is your answer, 34. Got it? Good. Okay. If that doesn't make sense, that's okay. We're about to get some hands-on stuff happening, okay? All right, who likes Tootsie Rolls?
Oh, really? No.
I eat it all the time. That's
Okay, good, thank you, I like you, all right. Tootsie Roll people, yes.
I love.
All right. All right, so, actually, right before, I forgot about this. Right before we do Tootsie Rolls, okay? Before we do the method of division, we teach what these vocabulary words mean. Especially in this class, kids are expected to use academic vocabulary. This is a couple slides, I just skipped through several. But it's in there, it should be. Anyway, so they need to be using this vocabulary: dividend, divisor, quotient, remainder, okay? We have a song to help them remember that, okay? And guess what? You get to help me do the song. Yes? Yes? Yay. All right, I'll show y'all first, okay? So this is what I do. And I actually stand on a chair. This is what I do. All right, so you guys stand up. Stand up. All right. Y'all know Pop Goes Weasel? Yes. Old school. You know Pop Goes Weasel. Okay. All right. And what happens is I have a kid, while we're singing, I have a kid, I don't have my stick right now, but they are pointing to the different things so that they know when we're saying these words, they're pointing to what it is, okay? And by the way, that is an example of partial quotient over there. It looks kind of scary. I promise it's not. We're going to get there, all right? So here we go. I'm going to sing it first, and then I'll get y'all to join me, okay? So we have the dividend's the start number, divided by divisor, multiply, subtract, add, out pops the quotient, out pops the quotient. Anything left behind smaller than your divisor, that's the remainder, that's the remainder. Okay, my motions are, most of them are pretty intentional, okay? So the dividend is the start number. We don't say it's the smallest number because when you get in 5th grade, it's not going to be the smallest number when we're dividing decimals, right? So we say it's the number that you have to start with. So the dividend is the start number, so you're taking your hands and you put it there. Dividend is the start number, okay? Now you're dividing it by the divisor. So this becomes the divisor. You're still pretending that your dividend is here. So your divisor, so divided by divisor, okay? Multiply, subtract, add, okay? That just represents all the things that we have to do, right? Okay, out pops the quotient. So quotient is your answer. It goes up top, right? So out pops the quotient, it's up here. All right, anything left behind, and I do this because it's behind me, just behind me. All right, smaller than the divisor. So I say smaller than, and I do the divisor because that was what was doing the chopping, okay? Smaller than the divisor, that's your remainder. That's your remainder. And we talk about sometimes with the remainder, you can throw it away. You can't do that with all remainders though. And we get to that in when we are doing word problems. Okay, y'all ready? Here we go. Ready? Here. The dividend is the start number, divided by divisor, multiply, subtract, add, out pops the quotient, out pops the quotient. Anything left behind smaller than your divisor, that's your remainder, that's your remainder. Now we do that super slow, and we do that super fast. You want to do it super fast? Ready? Y'all can do it, y'all can do it. Ready? Here we go. The dividend is the start number, divided by divisor, multiply, subtract, add, out pops the quotient, out pops the quotient. Anything left behind smaller than your divisor, that's your remainder, that's your remainder. Y'all did good. We also do it way faster than that, and it's pretty funny. Anyway. All right, y'all can sit down now. So that's the division song. The purpose of that song is not necessarily to teach them how to divide, but it's to so that they remember those words. And used to on CRCT, there were some crazy questions about if you multiply the dividend by this, what will it do to the quotient? And, you know, if you multiply the dividend and the divisor by this, what will it do to the quotient? Milestones is usually a little bit better, and they don't ask like procedural questions like that, but they would put it in a word problem kind of thing, to where they're having to do that same task, but not necessarily without the context of why they're doing it. Anyway, not that the milestones is, you know, I'm not trying to rave about milestones right now. Anyway, all right, so again, what's wrong with the traditional way? Absolutely nothing. It's more efficient, okay? And eventually, when they get to 6th grade, we want them to be doing that the traditional way. But right now, we want them to understand why they are dividing. So you're about to see why partial quotient helps them understand how to divide in real life, okay? So, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we could get in a group of, let's see, 5 and 4. You might want to actually get in to where, because you're going to have to like separate these, so you might want to actually, I'm going to move here. And honestly, you guys might want to move up here. You're going to tell me if I make you do that? All right. So. Isn't it awesome? You're going to be dreaming of that tonight. And you're going to be like, I'm so happy that Alexander taught me that. Y'all call me Cindy back one. Anyway. All right, so here's our problem. Okay, we have all these Tootsie Rolls. All right, all 4 of you and all 5 of you want the same amount. Okay, you want to be fair, right? So we're going to pretend that we are 4th graders. We do not know the standard algorithm. And by the way, if you were using the standard algorithm, what would you have to know about this? How many are in there? Okay. In real life, are you going to count the Tootsie Rolls? You're not going to do that. Would you really do that? So now what we're going to do is your task is to divide these evenly. But here's the thing. And I'm going to give each of you each group a piece of paper. One of you are going to be the secretary. So you're responsible for writing down what you guys do. Okay? All right. Good. You're going to use that paper and use that paper. Doesn't matter. Okay, you're good. All right. So, before all right. So, you are not allowed to eat any until we're done. Then you might. Then, if you worked cooperatively, I can't even say the word right now. If you worked well together, then you can each have 1. And if you worked really well, maybe you can have 2.
I'm getting 2.
Come on, anyway, so before you start touching them, I want y'all to come up with a plan. All right? So come up with a plan. How many do y'all want to take out to begin with? Or what would that look like? Okay, so come up with a plan. You have 1 minute to talk about it, come up with a plan, and then we're going to start working.
Like we should start with a number to divide, to give to each of us. Like I said, 5.
Okay. Okay. Y'all with
So y'all have to agree on it.
And
Agree on it.
Take them out in groups.
We'll just start going. And then after the 5 one, 5 again, another round.
I think we get left.
Should we go 5?
You say 10?
3?
I mean, we probably could
10
do
by
10,
5.
and then go
10, 5.
5 maybe.
I mean,
Go 10 first and then 5.
and then maybe if we after we do 10 each, we can look and see
Okay.
if
I would do it by
have
2.
enough to do by 5, because then
I'm
you might
just
do
looking
by
at
2.
it.
Okay. Okay.
All right, I think you guys are ready to start.
Okay.
All right, I'm gonna record what we've done, y'all.
Yeah. Are we doing now?
We do it or?
Do it.
Oh, all right.
Should we all just grab some in our hand and go 10? Yeah. Yeah. Count here. Here you go. You just count 10 for yourself. You know what I mean? Yeah. grab 10 automatically?
Wow.
Okay. So I got my 10.
Okay, 10. So we could probably do 10 again.
Okay. Take you to the casino.
Hey guys, I might get cheese. Two.
I have three. Yeah, okay.
I have three groups of 10.
4 groups.
Oh, you were.
Okay, you had 4 groups of 10. Let's take his 4th to here, and then we'll go in for 3 more. 4, and you need 1 more. 5. Okay, what's that? 2, 4, 6, 8, 10, 11 or less. 1, 2. So we're gonna have 1 remainder. Boom. So we end up with 27.
A lot of problems. Who gets the last one?
2 for you.
What's that?
2 for you.
That'll be 1 to 1.
Boom.
We're gonna eat it, but.
So how many do we have each? 27, remainder 1.
It looks like every group has it divided out. Figure out how much you have, and I see that each group has 1 left over, or some left over. Figure out, what would you do with that? Y'all decide. What would you do with that? Who gets to eat?
Throw it out. What was the thing?
Is remainder.
So you guys look very nervous, and I think that y'all made it. Y'all figure out how many Tootsie Rolls y'all had to begin with.
I wish I had all of these.
I would say 27 if there's not times 5.
And remember that they have done multiple.
Let's do, yeah.
So do you guys know how many each person has now?
Yes.
Okay, everybody has the same amount?
Yes.
We're good? What did y'all choose to do with that remainder?
Throw it away.
Trash, okay, cool. That's all right, a little wasteful, but okay. Now, I want to figure out how many were in the bag to start with. How many were in the bag to start with? How can y'all figure that out?
27 times 5 plus 1.
And y'all can multiply it any way you want, or you can use one of my strategies.
Plus this one, that makes 136. Yeah, that sounds right, yeah.
Yeah, the box.
You did the box.
I went
You did the
carry over.
Yeah.
I did the box.
I know my daughter had one remainder. I was like, so no, it's gonna have a remainder. There's no way around it. She's like, we can't.
R2.
Remainder.
I was like, we'll put the remainders on the back of the sheet.
Were y'all able to figure out how many were in the bag?
Yes.
How many were in the bag? Okay. How many was in y'all's bag?
137.
137. Okay, cool. So we had 136 over here and 137 over here. Cool deal. All right. Now, so you guys just learned how to do long division and check your long division with multiplication. Congratulations. I still see that. Good job. All right. So, does that make sense? Like what we just did? All right. Now, okay, if y'all want to, you can eat any Tootsie Rolls you want. Put the rest in the bag. Don't throw them away though, please, because I am going to use these with your kids. All right. But yeah, you're welcome to do whatever. You guys, y'all can go back and sit at your seats.
Oh, I was about to take green.
No.
You were saying,
All right.
but my oldest son, Jaden, who's now in 8th grade.
So you guys, there were four of you, right? So have
It made
137.
sense.
Okay.
Like that was hands down, like boom, 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 boom.
And there were supposed to be, by the way, there were supposed to be 136 in every bag, so obviously I can't count. Anyway, all right. There were four.
Got up and one fell off my skirt.
Uh-oh, all right, so that's okay, not a big deal, we're gonna go with what we got. So really, I'm at a really, really good center. All right, I'm going wanted to not, and y'all can kind of scratch out that problem if you want, if you wanted to do this as we're doing it together. But I wanted to go through your steps. Okay, so this group, you guys said you had 137. And so that was your start number, right? Do y'all remember what that's called? Start number is your dividend. Start number is your dividend, okay? How many people were you dividing that between? Four, okay? So if you had your start number and you were dividing it among those 4 people, what were you guys? You guys were the divisor, right? So that would be 4. Okay, now you guys, what was your start number?
136.
136, and remember that's called the what? Dividend. Very good. And how many people did you have?
5 is our divisor.
5. Oh, good. 5 is your divisor. Okay? All right, so these are your 2 problems that we just set up, long division. Okay? Let me show you what you did. All right? I need my reporters. Okay? What was your first step? What did y'all do first?
Dump bag.
Dump the bag. Then what did you do?
Take out groups of 10 for each person.
Absolutely. So if you took out 10, all right, we're going to put this up here. This method, by the way, is called partial quotient. Okay? So remember that your answers up here are called the quotient. All right? In standard, we just write it up here as we find it, right? Okay? But in partial quotient, we're going to kind of stack it on top of each other. All right, so each person took out 10. All right, so if each person took out 10, how many did y'all take out altogether? 40, right? Because if each person took out 10, really that's 10 times 4. And I really like what I heard y'all saying. Y'all kept saying 10 groups of 4, okay? Or, I'm sorry, 4 groups of 10. That's what I heard y'all saying, right? Guess what? My first graders in my advanced math class, they're infatuated because a lot of them have big brothers and sisters that are multiplying. They're infatuated with those stairs down there. So every day, I let them pick out an equation. And in first grade, I don't let them call it times. Okay? So we're not going to use the word times. Guess what word we use? Nope. What were y'all using? You said 4 groups of 10. So instead of times, and I teach my kids this, we go groups of. Okay? Groups of. Okay? And that helps them know, all right, this is, what I'm doing. Multiplying, I'm not just remembering weird, random facts, okay? I'm remembering how many groups of 7, I'm remembering like 8 groups of 7 is what, okay? So it gives them a little bit of meaning to those facts that they're having to learn. All right, so anyway, 10 groups of 4, 40. Okay, so you took that out, right?
Yeah.
Of that pile. That pile in the beginning, that was your dividend, that was your start number, and you literally took out from that pile. So you actually subtracted from your dividend. 7 minus 0 is 7. And I cannot do 13 minus 4. Now, in other classes, we would do this. 0, this is 13. Okay? But guess what? We noticed, isn't that the same as what I just had? Isn't that just an extra step? Right? So you can, if that doesn't make sense to do that, just say, what's 13 minus 4, and what is that? 9. Okay? So now we have 97, right? That's how many y'all had left after y'all each took out 10. What did you do next?
We did that a second time. We took
Okay.
another group of 10.
So I'm going to stack that here. And you did it again. You took out 4 groups of 10. So how many did you take out that time?
40.
Another 40. All right? 7. 9 minus 4 is 5. Thank you, because I was struggling for a second. All right. So now, in the middle, y'all notice that after y'all were taking it out, your middle started getting what? Smaller, right? So now, you actually had 57 left. Okay, even though you didn't know it, that's what you had. All right. So, what did y'all try next?
We did the 10 a third time.
Cool deal. Now we're living on the edge there. You're like, I think I can do it. I'm not sure. All right, so y'all took out another 40, correct? Okay, now you were left with 17. Uh-oh, can you do it again? What'd you do?
So we took out 3 at a time.
3 at a time, okay? So you took out 4 groups of 3, so in all you took out how many? 12. Okay, 17, and you took out 12. So that is 5 left, and you were like, ooh, what can we do?
Do one more time.
One more. So each person, 4 groups of 1, right? Which is 4. And you had 1 as your remainder. Now remember, anything left behind smaller than your divisor, that's your remainder. That's how you know you're done. When this number gets smaller than this number, you're done. That's your clue. But this doesn't make sense yet, right? So how did y'all figure out how much you had in all? What did you do? You added them together, right? If you didn't, I saw this group, what they were doing is when they were pulling them out, at least one person was keeping them in their groups of 10, okay? So that when they added them back up, it was easy to add, right? Cool deal. Some of you were just like, oh my, okay? And then you had to do what? Count by ones, right? Okay? So, but nice and neat right here, this makes 34, remainder 1. Cool?
Yeah.
All right, so you guys, what did y'all do? What was your plan? And I'm going to kind of move through this a little bit faster, but what was y'all's plan? What did you take out first?
10.
10? Okay, but in this case, you had 5 people, so 10 times 5 is 50. So we subtract that.
That's 86.
Thank you. All right, 86, okay? And then what y'all do next?
Another group of 10.
Cool deal. And that is 50.
36.
Good. Perfect. What'd you do?
Then we did 5.
5? Well, so y'all's plan, oh, it was similar until here, right? Then they're like, oh, we can take out 5. 5 times 5 is 25. And that is
left over.
11.
And then we did 2.
2. Nice. 2 times 5 is 10.
So we had a
And now we
remainder
have
of
1 left over. Remainder 1. And that would be 27. Cool. All right. Once y'all were done, I asked you to figure out how many were left in your bag, right? How did y'all do that? Any volunteers? Tell me how y'all did that? Yeah.
With the area.
Okay. So you used multiplication. What did you choose to multiply?
4 times 30 times, broke 30 into 30 and 4.
Okay, so you did 34 times 4. So 30 and 4, and I'm kind of doing this backwards, but anyway, it's okay. Times 4, 1, 0, 12, 4 times 4 is 16. And 120 plus 16 is 136. Okay, thank you. Woo! I was struggling there for a second. Now, but that's not the number you told me. You told me you had 137. How did you figure that out?
Because we have remainder.
Well, what'd you do with that remainder?
Added it.
Oh, you just added it, right? Plus 1, 137. Now you know how to check your division with multiplication, because we know division and multiplication are, my kids say, inverse operations. Okay, so opposite operations, they undo each other. All right. So, does that make sense? We're good? All right, now, this is not where we stop, okay? This is where we start. And you can tell, I'll just leave this one up for a second. Did we have to do 10 and 10? What if y'all would have done, y'all were at first starting talking about taking out 5? Would that have worked? Could you have still done it?
Yeah.
And instead of 10 here, it would have been 5, and then you would have had to do another 5, and another 5, and another 5, right? And another 5, and another 5, and it would have been a really long problem, right?
We could have
Okay.
also done
You could have, absolutely. And if you would have known this number right here, if you would have known this number, you would have probably been able to estimate that, okay? Because you would have been, okay, 136, and remember, we already know 10 times 5. We know 20 times 5. So you would think, okay, can I do 20 times 5? What would 20 times 5 be? 100, right? Can I subtract 100 from 136? Yes. So, what I am in my, accelerated math class, we have already taught in 5th grade, we have already taught the standard algorithm for division. Because remember, they have to do 5th and 6th standards, and standard division is the 6th grade all kids will learn it in 6th grade. What we're doing in the advanced 5th grade math class, those are the kids that are still, they're doing the 5th grade standards, but at a higher level. I'm trying to get them ready for the standard division, okay? And this is how I get them ready for the standard division. We do that estimate, okay? So for 136, I would say, okay, divided by 5, I would say, what can you multiply by 5 to get as close, what multiple of 10 can you multiply by 5 to get as close to 136 as possible? And I tell them their answer has to be one non-zero digit followed by zeros. Because I don't want them trying to figure out 15 yet, okay? I don't want them to go that far. But what I want them to figure out is what? 100, right? Or I'm sorry, 20, so that we get to 100, right? Now, I'm going to write this 2 different ways. 136 divided by 5, okay? So this is going to be my standard way. This is going to be my partial quotient. All right, but this is their goal, and this is, right now, if your kids are doing this, I'm happy, okay? By the end of 4th grade, I want them to be doing it this way. It's a more efficient way. How, we call it the Price is Right. As close to the actual number without going over is what we're going for, okay? All right, so for here, I would say this would be 20, okay? Traditional way. 5 times what is, again, I can't talk. All right, how many times, thank you, how many times will 5 go into 1? Can't do it, right? So, how many times will 5 go into 13? 2.
Yeah.
2, okay? All right, back over here. 20 times 5 is 100. Subtracting, now I have 36. Over here, standard way, 2 times 5 is 10. Subtracting, I now have 3. Okay? All right. And I hope I'm not confusing you going back and forth. I'm hoping this is helping you not confusing. Okay. So, all right. So now I'm thinking, well, 5 times what is 36? As close to it without doing it. What is it? 7. 7 times 5 is 35. I subtract and I get 1. Okay. Anything less than my smaller than my divisor is my remainder. So therefore I am done. I'm sorry, this happened. Y'all fail. Y'all fail. I'm like over here. Okay. All right. So we have 27 remainder 1. Okay. So over here, I had this 3. What's my next step? Bring down to 6. Okay. And I do that, and now I have 5 will go into 36. How many times? 7. 7 times 5 is 35. Subtract. We get 1. Remainder 1. Okay. The difference is in these, and this is literally what I do with my kids, teaching them how to do the standard operation, okay? I say, okay, let's look at the similarities between these. What do y'all notice is different, okay? What does this one have more of than this one? It has more what? Zeros, okay? So what happens if do I need my zeros? What is the purpose of my zeros in this problem? To make sure that my numbers are what? In the right place value, okay? So the standard way, some mathematician a long time ago, really smart guy, or girl, sorry, okay, figured out a pattern. They figured out that if they were to write these numbers in this particular way, that the place values all worked out, right? So in here, what am I doing? I'm using the zeros for my place value. So if I covered up that 0, this 0 is missing too, right? If I covered up that, right? Okay. All right.
Yeah.
Same thing. All right. So this is where we're going with this. Okay. So this is my goal by the end of this year. I want all the kids doing this way, and I call it stair steps. Okay. They're trying to get and we also call it Price is Right. All right, as close to the numbers without going over. I actually developed a kind of a Google form that they practice this skill before they even start doing it with division. So it's like 5 times what gets me as close as possible to 136, and the answer is 100. yeah, I'm sorry, the answer is 20, they have to put that in there, okay? So this is the goal for partial quotients by the end of this year. This is where I want all of these students, okay? But right now, they're understanding it like this because that was natural, right? Y'all did that naturally. No one taught you how to do it. Y'all came up with this plan on your own. So it's a very natural way to divide. Cool? All right, so does that make sense? That's standard, standard way? Now in 4th grade, we only do 1-digit divisors. So single digits here, and we go up to 4 digits in the division. Okay, so 4 digits divided by 1 digit. In 5th grade, we start doing 2-digit divisors. And we still teach it that way. We still teach it partial quotient. And I developed, so there's 2 different Google Forms to help them get to that most efficient way right there. Okay, and one of them is 2 digits and one of them is 1 digit. And we do that to just help train them get to that skill. So in a couple weeks, you're going to, that's going to be for, we'll start it in class, and if they don't make a 100 on it, they have to keep doing it until they get 100 on it.